I'd like to invite Lena Hall, who's with developer relations at AWS, to come and chat about sort of navigating the complexity of decision making for resilient data architectures. It's of course hard to operate in a world of hundreds of trade-offs, and it's a fascinating time to be an architect, data engineer, or cloud practitioner. So Lena is going to sort of dive into that and give us a little insight into how to learn, how to shape our mindset, and a decision framework to best handle this fascinating time. Thank you so much for joining us, Lena.
Thank you. Thank you, Daniel. Hello, everyone. I am extremely honored to be invited to present at this amazing conference and help raise support for Ukraine. I am really beyond grateful to the organizers, volunteers, speakers, attendees, and anyone who donated or acted in support of Ukraine. What is happening in Ukraine really matters to me a lot personally. My ancestors and relatives are from Ukraine. I was lucky to live in Ukraine for a couple of years. And ever since I got closely familiar with Ukrainian people, I've been ultimately amazed by how open minded, creative, united, courageous, and free these people are. So if you look at the history of Ukraine, at the poems and literature, at the anthem, you will see that there is a record of challenges that defined the character and the culture of the people to withstand difficulties and develop resilience. And resilience is the topic that I've chosen for this talk. The whole world has seen what true resilience is, watching Ukrainians stand up for their independence. So, resilience is an important concept when facing a crisis, a sudden change, or a difficult situation. This concept applies both in the world of humans and in the world of technology. So, today I wanted to focus on the topic of resilience, what we can observe about it, how investing in resilience affects systems we build in the world of technology and in data architecture in particular. So, what is resilience? It is having an ability to handle change or disturbance that break through the robustness barrier. Resilience is how a system responds to a crisis or a stressor and how it is able to move forward despite adversity. The more resilient a system is, the larger a disturbance it can handle, and the crisis could be big or small, sudden or progressing, but in any case, the disturbance is something that carries potential damage or change to our system. Another common way you may find to define resilience is stability in the face of barriers. But there is a huge difference between stability and resilience. Maintaining stability and resilience requires effort in both cases. But there is a difference where that effort is directed. So let's take a look at the system in the face of a challenge. So with stability, the work is directed at keeping the system the same and unaffected by the challenge. Stability directs the gravity towards today's state of the system and focusing on blocking possible deviations from it. Stability implies restrictions on moving forward. With resilience, the work is directed at adjusting to the change, navigating the new path forward, and learning. It also allows the system to change, even if the change is challenging, and eventually getting to a better place, finding a solution that would keep the further momentum of the system on track. So, resilience implies keeping the freedom to move forward to our goals while maintaining our core values as a priority, even in the face of difficulties. The cost of resilience is the initial lack of stability and effort required to prepare, unite on the mission and goals, handle the change, and enable autonomy in crisis. Cost of stability is making concessions to keep the status quo, potential slowdown of change, and reduced resilience. Change is inevitable. During design, architecture, execution, and maintenance of technical systems, change really is inevitable, natural or gradual in case of shifting business needs, or drastic and spontaneous during underlying environment outages, spikes, or any unknown unknowns. And resilience really matters during the change because it can help us stay on the right track. It is a muscle that can be developed to increase the speed of response to change as well. Path to resilience isn't purely a technical or technology choice. It is a decision that humans can make. A lot of the work that that makes organizations and architectures resilient is shaping the right culture and recognizing that the systems we build are socio-technical in nature. A lot of qualities and behaviors that are crucial during a crisis are actually formed before the crisis happens. Resilience is proven in difficult situations, but it is shaped by how we approach day to day operations. And it is empowered by the culture that is formed throughout day to day habit. The first step on the path is creating clarity of overarching mission, core values, and priorities. What principles will unite teams across the organization to act cohesively to facilitate further business growth, innovation, or progress? What will unite individuals and drive cohesion across teams in crisis? It's important to note that clarity on the mission doesn't imply centralization. United on priorities doesn't mean limiting options or dictating the path that each team must take to build systems. Also, when everyone is aligned, then everyone cares about end to end projects versus just parts of them and feels more confident stepping in when things deviate from the plan. It is helpful when teams and organizations take an intentional approach to examining communication, interaction, or dependencies across teams and roles for bottlenecks or anything that may slow down or interfere with action. Making technology decisions that remove bottlenecks, reduce friction to change, and support innovation. Another step on the path of resilience is increasing autonomy and trust for teams or individuals to take the right action while handling a sudden change or incident. It is important to empower the ability to make an informed and competent decision to move forward in the absence of immediate opportunities to consult for advice due to the urgency of required action. In addition to shaping the culture, there needs to be a solid technical foundation as well to support deviations from the plan and deep understanding of concepts and trade offs by data engineers. So, how can we provide that? There are several aspects here. First, we need to provide opportunities and invest time to educate data engineers and other team members on concepts and paradigms that can help better navigate trade offs and ambiguity. We have seen exponential growth in technology options because we have been enabled to do more, but it also introduced some complexity. The concepts that we're working on the day-to-day basis are complex, and there is a lot of them to digest and understand. They're nuanced, and I remember when I was getting started with the topic, there were already plenty of concepts to get familiar with: analytical and transactional processing, ETL, data marts, and so on. But just imagine someone who is entering this space in 2022 and looking into a concept like data mesh or delta lake. I really love these concepts, but in reality, they're composed of dozens of paradigms that you need to know and make sense of it. It is a pretty deep rabbit hole. So the gist is to be comfortable and confident in making choices, you not only need to know a variety of concepts, but also dive deep into each of them to really know what the underlying trade offs and limitations are. And they aren't always exposed. There isn't a single approach or an industry standard that would work for most organizations the same way. It is too specific. So, if we want to make a conscious decision, it obligates us to dig deep. With the amount of growing variety, lack of standards and mechanisms in the data ecosystem, it becomes harder to evaluate these options to know that we are on the right track to making the right choice. It also becomes difficult to make progress in velocity of iteration quality, and resilience of data systems without it becoming an organizational priority. Because data teams are getting overwhelmed. Data systems are at the layer that many other layers rely on. And there are always new functional needs that are prioritized by the business. I've seen that due to complexity and effort, a lot of the time their focus is on choosing the solution that meets most functional requirements of today instead of designing for change. This happens when resilience isn't intentionally prioritized during design, planning, and evolution of systems at organizational level. So we really need to rethink the baseline of what a working data architecture means to include things like handling change and crisis response as a priority close to functional requirements, which will really help inform the choices we make today to build better resilience for dealing with inevitable change in the future. In the world of applications and services, embracing DevOps has been a good example of a prerequisite for enabling things like resilience. In the world of data, the counterpart of DevOps is DataOps, which actually isn't a one on one parallel to the definition of DevOps. So today, it's very common to see DevOps adopted as a best practice in many organizations. Data ops, not so much yet. Data ecosystem is much more cumbersome and bulky to change. It's less ephemeral. Decisions tend to be more sticky. It's challenging to troubleshoot. And in a sense, most unexpected problems are tackled on an ad hoc basis. So, data ops was created to bridge the gap between data analysts and data engineers. Traditionally, these two groups had different goals and responsibilities, but with the progress of big data analytics, this has really changed. Data ops is like DevOps in a sense that both are based in agile and continuous improvement thinking. Data ops is designed to streamline the development of data driven applications, build high quality data and analytics solutions at a more accelerated pace with better reliability, higher quality of data available. And it can be achieved through several methods, including automating manual data collection and analytics, increasing reusability, democratizing access to data, monitoring data pipelines. There are also new concepts like data observability, which is really required to ensure accuracy and reliability of data at a given time, in addition to just building new data pipelines. And data observability is organizations' ability to fully understand the health of their data systems. So, overall, in the world of application solution architecture, there has been more progress to build up strengths to focus on incident response and overcoming critical situations than in the world of data. So, we need to ramp up to make a difference in response during crisis and troubleshooting unknown unknowns. We need to prepare a solid technical foundation. We need to be prioritizing areas of data engineering and data ops that create autonomy and reduce risk of crisis in the first place, help troubleshooting, ensuring data observability, data quality, reliability, self-serve capabilities. So for the rest of the talk, I would really like to focus on two things: examples of concepts and trade-offs in data systems and questions we need to be asking ourselves about technical capabilities and requirements that can really help us be set up for success in increasing resilience of data systems. So, we need to be intimately familiar with existing concepts and paradigms, how they map to our goals technically and organizationally, how they can help us choose the right solutions for resilience. There is a note that I remember from two great US musicians, Leo P. and Grace Kelly, where they mentioned that there is a lot of gear out there, but it's not the gear that defines your sound. Gear can help you get to the sound that you hear in your head. So, concept is something that helps you hear that sound in your head first, and then you can decide on the required gear. So let's take a moment to review the concepts that one must really know if they're in the space of data and analytics, to understand which aspects could be helpful when building up resilience. Data warehouse. It is like having a large and unstructured closet organized specifically for, let's say, wine storage, or like a professional freezer room at a restaurant where it's temperature controlled. It has specifically shaped shelves and cabinets for different types of vegetables, meats, pantry items. We know who exactly is going to use these rooms and how it will be used, searched for, retrieved. It is really great for systems with clearly defined business scenarios, not a lot of uncertainty and need for change or predictive analytics. And at the same time, it's rather restrictive and expensive to change. Data Lake takes a bit of a different approach. We can think of it as a large closet room in a house which doesn't have restrictions on dimensions of objects that you can put there. You have much more flexibility. You don't have to know exactly why you put something in there. You can decide later on how you're planning to use it, which enables more scenarios where data could be used by many different parties for different purposes and allows flexibility. But as you can imagine, if everybody starts to using that closet at the same time without any rules, it becomes a mess. So with Data Lakehouse, we can achieve more structure and order. We can have more flexibility when working with data without necessarily enforcing structure at a built-in level, but delegating that to coordination one level up. So thinking of it more as a best practice or guidelines that users can follow to ensure that data is in the right shape and form, that it's manageable, still allowing a lot of flexibility. With that, you'll see two approaches, more centralized and more decentralized. The traditional one has been a centralized approach where there is one central data repository, variety of operational and business producers and consumers interacting with it. Many organizations are successful with it. In some cases, with so many users and use cases involved, after a certain point of growth or momentum, it starts slowing down innovation and change. So there are alternative, less centralized solutions. One of them is Data Fabric. It's about observing and discovering patterns and tendencies, automating repetitive tasks, making connections between similar entities or sources, and constantly improving integration for common scenarios. It relies heavily on metadata. So, first, it learns about what exists and how it's used over time, and then it uses advanced embedded machine learning techniques to understand how data management and integration can be optimized to improve the system. Also, there is data mesh, which is not just a technical or architectural notion, it's a socio technical paradigm. So, if we use the previous metaphor of a closet, it's not really thinking of a closet as a storage space and about housekeeping operations to manage it, but it shifts the mindset to thinking about how we can accomplish what we want with the objects that might not even be stored in that exact closet. What can be done with it, who can benefit from it, and organizing it in a way where some household members would have decentralized ownership of specific responsibilities and they can rely on each other to accomplish the goals that they need. They can also define standards for understanding what objects exist, how they can be discovered, what is the level of shape they need to be kept in, who can access them, what are the mechanisms in common to help accomplish shared goals. The point is in finding ways to evaluate these concepts and choose the ones that align to the goals and operation of your projects or organization to build up that reliability and resilience. So we won't feel certain until we have really confronted our initial solution with other solutions, even if the first solution proves to be the right one. The next step is defining preferred capabilities that could help us grow the resilience muscle. So think of what type of automation capabilities you would need in your system. a simple API or advanced infrastructure as code tools spanning multiple cloud providers. It's important to look at whether the exact level of granularity of operations you want to be automated is supported, whether it's missing or not covering all that you need. It's good to set expectations for workload flexibility and elasticity. If you expect to build a self-serve platform, how well does it need to support scale down to zero? How fast can it scale to the maximum capacity you need? Also, think of interoperability that you expect between components in your system. What are the communication standards or formats that need to be supported? And what is the level of collaboration that you would expect between teams within your organization that might affect how you make architectural decisions? How much do the teams share data? How much do they rely on each other's work? It's also good to think about security and access control approach. What granularity do you need in which you can set up and access permissions within your technical options? What level of access control do you need? Row level, column level? Can you manage it from different accounts belonging to, let's say, different organizations or across cloud providers? Also consider whether you need observability into your system. Do you want it? Do you want to be able to answer questions like, is my system up or down? Or do you need more details, high cardinality, high dimensionality, and explorability to make it easier to debug and understand what's going on with the data in your system? Think about what is required to maintain data quality and trust. So that might be defining SLOs for things like availability, throughput, refresh frequency, response time, quality, how accurate the data is. Look into potential restrictions that most commonly happen with cloud providers or technology platforms, depending on which quotas or resource limits they have, which may affect your ability to use the technology in a particular way. And another really important aspect, I think, is looking into open standards, open protocols, and open source integrations. Things like Delta sharing, open metadata, open lineage are good examples. And same goes for how active, welcoming, or supportive the community is. We've seen great technology that would have had bigger chance for adoption if it chose a more open path and stronger community around it. And here I want to especially emphasize data observability. You're probably all familiar with observability, which has been there has been a lot of work done by wonderful companies like Honeycomb. Charity Majors has some of the best resources on it. The concept of data observability was first coined in 2019 by Bar Moses, who currently runs a data startup focused on data observability called Monte Carlo Data. So, to quote her definition, data observability is organizations' ability to fully understand health of data in their systems. So it operates the concept of data downtime, which is periods of time when data is partial, erroneous, missing, or inaccurate. So introducing data observability eliminates data downtime by applying best practices learned from DevOps to data pipeline observability. It uses automated monitoring, alerting, triaging to identify and evaluate data quality and discoverability issues. And it leads to healthier pipelines and more productive teams. So, data observability operates several components that provide valuable insight into the quality and reliability of your data. Things like freshness, how up to date your data tables are, when are they updated? Distribution, it gives us insight if our tables can be trusted based on what is expected from the data. Volumes, which indicates the completeness of the data tables and offers insights on the health of the data sources. Schema, meaning if there is a change in the organization of data that can indicate broken data. So monitoring who makes that change, when did this happen, can really provide good pointers to the root cause. And lineage, of course, which is telling us which upstream sources and downstream ingesters were impacted, which teams have been generated data, and who is currently accessing it. So, good questions to ask yourself when you're evaluating tools for data observability are: can it connect to your existing stack quickly? Or do you need to modify existing data pipelines, write new code, choose a specific programming language? Can you monitor your data at rest without requiring extracting that data from where it's currently stored? How much configuration does it require? Does it support anomaly detection? What is the level of richness of data it provides, of metadata that it provides? Can it really be enough and sufficient for troubleshooting? So after we clear on these preferred capabilities, we're more ready to make our actual technical choices. So example questions to ask here are: does your option support workload sharing or multi-tenancy of workloads? It is really important for the ability to use these tools as a part of shared data infrastructure that can really help resiliency. Another one is: does the technology you're looking into support no copy data sharing? Does the technology support bringing compute to data located elsewhere? How well does it support time travel versioning? How does it manage schema evolution? How exactly can we capture and provide data lineage to help tracing the data errors back to its potential root cause? So there are hundreds of good questions to ask, and it's worth doing it ahead of time if you plan to evaluate your design for change. So, to summarize a lot of what we've talked about, resilience isn't just about the moment of crisis or the moment of change. It's shaped by the culture that we nurture every day, and it stands on the technical foundation that we build, on our understanding of trade offs, all of which improves our readiness during crisis, but also during change. It is a muscle that we can and we should grow when working on data systems. And upfront investment in making resilience a priority will really pay off. And we can see that if we look at the future trajectory of data and analytics ecosystem. So the first observation is we will be shifting more and more towards thinking about technical systems, not just from a technology perspective, but taking into account how organization works, how people collaborate, applying these considerations when we design our systems. So we're moving away from technical to socio-technical design and architecture. And I can see more and more companies are recognizing that. We will continue seeing major focus on data quality, trust, data observability, and governance. These areas is where we still have gaps to address, and in turn, it will further democratize the path to machine learning and further analytics. So we will see more analytical insights flowing back into operational systems, and we'll see smoother bridge between data and AI and ML use cases, and also more metadata driven embedded machine learning. We will be seeing more democratization of getting value from data. This is because data is becoming the first class citizen, and more organizations are looking into data as product model to have a better way of offering the data to its internal and external users, both operational and analytical. And I'm guessing that we might see this emerge at a public cross-organizational level, where it becomes easier to offer, serve, and share data between businesses in a secure and trustworthy manner. And this also leads to expansion of data-related roles. So where it's not just sufficient to have a general data engineer, we'll be seeing new types of roles like DevOps or MLOps engineer, data product owner. And with all of that, we are in the path to better convergence on open standards, formats, and protocols, but we're still not there yet. We should expect even more projects, products, and experiments before we converge. So complexity and change is definitely here to stay for a while longer. And design for resilience will be a good investment that will help you stay on the right track while navigating the change. Um, I hope you enjoyed the talk. I'm going to leave you with this nice quote. Thanks for attending, and I'm wishing you all the best. I'll post my slides on Twitter later today. My messages are open in case of any questions. And thank you. Thank you so much. Slava Ukraini.
Well, thank you so much for that talk. Just on a personal note, really like the analogies you were using to describe the data lake, data warehouse, data lakehouse, and all that stuff. These are terms that were a bit unclear for me, and now I feel like I have a much better understanding of them. So thank you so much for that. One of the comments that came up from multiple sources in the chat was really just love the slides. So excellent slide design, coloration. So kudos on that. So we'll give the audience a moment to send in their questions. Of course, as with all the talks, I've been taking a lot of notes down, and this has come up time and time again today, talking about this term, socio-technical system,
Yes.
right? Like technology is people, right? This talk is interesting because it focused a lot on data ops and data resilience and whatnot. But how does that then turn around and tie back into human resilience, right? What's that relationship look like?
Yeah, I think it's a really interesting question because when teams are super overwhelmed, there's almost no time to think about how are we coping with change and how are we planning for the future versus just handling the bombardment of requests that we're getting today. And I think now that the data ecosystem is oversaturated with problems and the stakeholders are recognizing that the teams really are overwhelmed by this, and it's time to stop and rethink how can we better prepare for clearing the path for change, because otherwise the data engineering team becomes a real bottleneck. So it comes down to the leaders rethinking what is the priority. If the priority is just built for today, then it's going to happen that way. But if the company leaders prioritize that we want to invest in our culture and in the people and in removing bottlenecks, not only from the technical side, but also from communication between teams and how we enable self-serve platforms to share data, and that depends on that communication and interaction between the teams, then you can see how once we run into that bottleneck, it triggers a lot of the conversations that aren't purely based on technology. It goes back to working backwards from what is really important for the organization and whether they're okay with saying, yeah, let's keep it a centralized monolith and deal with issues as they come, or do we want to make incremental improvements and start by communicating to people that it is a priority to us.
Yeah, no, that makes absolute perfect sense. In talking about kind of prioritizing things, in fact, that leads to an interesting question. You mentioned sort of this idea of resilience versus stability as almost like a competing system, right? Opposite ends of a spectrum. Are they in competition, or is there actually more of like a rubber banding effect where it's two
It's
sides
a
of the same
definitely
coin?
rubber
Like what's
band.
the deal there?
Yes.
Okay.
When I mentioned that they are slightly different, is that when you are training your resilience, you might not experience as much stability as you've had before when things are going as usual. So you will sacrifice the initial stability while you're going on the path of adjusting to the change and getting new skills, reshaping the culture, because it does mean change, and change is slightly different than stability. But overall, there will be periods of varying level of stability when you're working on your resilience. So, but this concept is frequently getting confused by organizational leaders, where when they say we want resilient systems, sometimes what they really mean is we don't want any issues to happen. We want things to stay the same. This is not the same.
Right. Yeah, of course. That makes perfect sense. As it turns out, words have meaning.
Yeah,
Right? Yeah, exactly.
for
All
sure.
right. Well, thank you so much for taking the time out to share the super interesting and really just chock full of good information, super informative talk. I really really appreciate you coming out and just sharing with us today.
Thank you so much. Really excited for this conference. Thank you for all the work that you've put in there.
Thank you very much.